Ganit Prakash, class 10, chapter 3, theorems related to circle. So there are some theorems and there are some properties of circles. We have to remember the properties and prove the theorems and also apply the theorems and properties in solving problems. Okay, so let us start with a property. In the same circle or in equal circles, equal chords intercept equal arcs and subtend equal angles at the center. What does that mean? It says that in the same circle or in equal circles, if we just clone it, we will get another circle, so it will be equal circles. So it is the same thing. So we'll take one circle, same circle. So this is the circle, okay. This is the center. What is a chord of a circle? It is a line joining one point on the circumference to another point on the circumference, and it is not the diameter. That is a chord joining any two lines on the circumference. If a line joins any two points on the circumference which is not a, and the line is not the diameter, so it is a chord. So this is a chord. Suppose we give it a name AB, and it says in the same circle equal chords. Suppose we draw another chord C D, and AB is equal to CD. If that is the case, if AB is equal to CD, these two are chords of the same circle. Then equal chords intercept equal arcs. What does it mean? The arc that we get from this side, this is the center. Okay, so let us measure the arc of this CD from this side, on the topmost side, from our direction CD. What is the topmost arc? This is the topmost arc, right? So it intercepts this arc CD. This is the arc. And what is the arc subtended? What is the arc intercepted by AB? Right? Because this is the center and we are taking arc of this chord in this direction. So it is on the opposite side of the center. So we have to take the arc in this direction. So these two arcs CD and AB are equal. That is the property. And subtend equal angles at the center. What does it mean? Let us join C and O, the center. Okay, this is the center. And B and O. So we get an angle here, right? Now again join AO and BO. This is another angle here. So this arc subtends this angle at the center, and this arc subtends this angle at the center. These two angles are equal. So that is what this property says, that in the same circle or in equal circles, same thing, equal chords CD and AB are equal. These two chords are equal. Then they will intercept equal arcs. This arc CD is equal to this arc AB. Okay? And the angles produced by the chords at the center and this one, these two will be equal. So arc CD is equal to arc AB, and angle COD is equal to angle AOB, and AB is equal to CD. So this is a property. You don't have to prove, but you have to remember it. Okay? Another property of circles, it says that in the same circle or in equal circles, the chords which subtend equal angles at the center are equal. In the same circle or in equal circles, the chords which subtend equal angles at the center are equal. So what does that mean? We take a circle with center O. Now let us take two chords. AB and CD. Okay. What is a chord? Chord is any line which joins two points on the circumference of the circle and is not the diameter. It is not the diameter. So it joins any two points on the circumference of the circle. So we have drawn two chords AB and CD. Now it says that the chords subtend equal angles at the center. Let us join these two points and these 2 points. So we get this circle. This chord subtends this angle, and this chord makes this angle at the center. Okay, so it is given that AOB is equal to COD. These two angles are equal. If that is the case, then the chords will be equal. If AB and CD are two chords which subtends equal angles at the center, if we join these lines, we get this angle, and joining these two lines, we get this angle, and these two angles are equal. And if that happens, if that is the case, then the chords are AB and CD, these chords are equal. Then AB is equal to CD. This is also a property of circles, and you don't have to prove it. Okay, just remember it, and it will be used in applications. Okay, the proof is not required. You just have to remember the property, that If the subtended angles are equal, then the chords are equal. It is kind of converse of the first property that we did earlier. So the third property, another property of circles, it states that one and only one circle can be drawn through three non-collinear points. What does that mean? What are non-collinear points? Points which do not lie on the same straight line. They are non-collinear points. Suppose these are non-collinear points, then we can draw only one circle through it. There is no way to draw more than one circle through 3 points. This is 1 point, this is 1 point, this is 1 point. So only one circle can be drawn. The property says that if there are 3 non-collinear means the points are not on the same straight line. Not on the same straight line. Okay. These are on the same straight line, but these are not on the same straight line. Okay. So if there are 3 non-collinear points, then we can draw only a single circle through the points. That will go through the 3 points. Not more than one circle we can draw. That is the property. And this property also, you don't have to provide proof. You just have to remember it to be used in applications later. Numerical problems may come, okay, where this property will be required. We have learned about 3 properties of a circle. The first property was that in a circle, in the same circle or similar circle, equal circles, if there are 2 chords which are equal, if AB is equal to CD, if there are 2 chords A, B and C, D which are equal to each other, same circle, if A, B is equal to C, D, same chord, then they will produce the equal angles at the center. This angle will be equal to this angle. That means angle AOB will be angle COD. And the arcs they produce also will be equal. Arc of AB, arc of CD. Okay, this is the first property. And second property stated the same thing. It was a converse of the first property, that in the same circle, if 2 chords produce subtend equal angles, AB and CD are two chords. O. This is O. If they subtend equal angles at the center, if AOB is equal to COD, then AB is equal to CD. Okay, this is just a converse of this theorem. So you don't have to prove any of these properties. And the third property is that between, if there are three non-collinear points, then we can draw only one circle through it. That is also a property. And this also, it need not be proved. Okay, just remember it. So we got three properties, that equal chords subtend equal angles, and if angles are equal, then the chords are equal. And the third one is that we can draw only one circle through three non-collinear points.